Hey there, science lovers! Ready to have your mind blown by some crazy physics facts? Let's dive right in. We're about to take a wild ride through the cosmos, exploring the weird, the wonderful, and the downright unbelievable. From the speed of light to the mysteries of quantum entanglement, we're going to uncover the secrets of the universe that'll make you question everything you thought you knew. Alright, speed demons, let's talk about the fastest thing in the universe, the speed of light. We're talking about a whopping 299,792,458 meters per second. That's 7.5 times around the Earth in just 1 second. Imagine trying to give a speeding ticket to a photon of light. Do you know how fast you were going? Yeah, officer, the speed limit of the universe. And get this, nothing with mass can ever reach the speed of light. As you approach the speed of light, things get really weird. Time slows down, length contracts, and your mass increases. So, next time you're stuck in traffic, just be thankful you're not racing a beam of light because you'll never win. Ever wished you could go back in time and change something? Well, according to Einstein's theory of relativity, time travel might actually be possible. You see, time is not absolute, it's relative. It's like saying, hey, meet me at this location without specifying the time zone. Could be morning, could be midnight, total chaos. Now imagine warping space-time so much that you create a loop, a shortcut through the fabric of reality. That, my friends, is a wormhole, and it's theoretically how we could travel through time. But hold on, before you go building a time machine in your garage, there are a few catches. First of all, we haven't actually discovered wormholes yet. They're still theoretical. So, while time travel remains a tantalizing possibility, for now it's best to stick to reminiscing about the past and dreaming about the future. Black holes, the ultimate cosmic vacuum cleaners where gravity is so strong not even light can escape. But here's the thing, they're not actually holes. Think of a black hole as an incredibly dense object like a star that's collapsed in on itself, squeezing all its mass into an infinitely small point called a singularity. Now imagine wrapping that singularity in an event horizon, a boundary in space-time where the gravitational pull is so strong nothing can escape, not even your cat's curiosity. Anything that crosses the event horizon is gone forever, lost to the abyss of the black hole. So the next time you see a hole in the ground, just be thankful it's not a black hole, because that's one rabbit hole you don't want to go down. Get ready to enter the twilight zone because we're about to talk about quantum entanglement, one of the weirdest and most mind-boggling phenomena in physics. Imagine two particles linked together in such a way that they share the same fate no matter how far apart they are. You measure the state of one particle and instantly, you know the state of the other, even if they're light years away. It's like having two coins flipped at opposite ends of the universe, and they always land on the same side. Heads, heads, tails, tails, every single time. Spooky, right? Even Einstein thought this was too weird, calling it spooky action at a distance. But here's the thing, quantum entanglement has been experimentally confirmed time and time again. Quantum entanglement has the potential to revolutionize computing, communication, and maybe even teleportation. So the next time you see two things that seem strangely connected, remember quantum entanglement. Remember that feeling after a big meal, when your stomach feels like it's expanding? Well, the universe can relate because it's expanding too. But we're not talking about a few extra inches here, we're talking about billions of light years. It's like baking a loaf of raisin bread and the raisins are galaxies moving further apart as the dough rises. And guess what? The expansion is accelerating like the universe can't wait to get bigger. It's like someone keeps adding more yeast to the cosmic bread dough. But what's causing this cosmic expansion? Scientists believe it's due to a mysterious force called dark energy, which makes up about 68% of the universe's total energy density. Think of dark energy as the opposite of gravity. While gravity pulls things together, dark energy pushes them apart, like an invisible hand stretching the fabric of space-time. So the next time you feel a little cramped, just remember the universe has got you beat when it comes to expanding. Light, it illuminates our world, allows us to see and travels at the fastest speed possible. But here's the thing about light, it's a bit of an enigma, a shapeshifter, a master of disguise. You see, light can behave both as a wave and as a particle. When light travels through space, it acts like a wave, spreading out like ripples on a pond. But when it interacts with matter, it acts like a particle, like tiny packets of energy called photons. This dual nature of light, known as wave-particle duality, is one of the fundamental concepts in quantum mechanics, and it's essential for understanding how light interacts with the world around us. So the next time you flip on a light switch, take a moment to appreciate the mind-blowing nature of light. Gravity, it keeps our feet on the ground, prevents us from floating off into space, and makes sure what goes up must come down. But here's the thing about gravity, it's not actually a force. I know, mind blown, right? We've all been taught that gravity is a force that attracts objects with mass. But Einstein came along and turned our understanding of gravity upside down. According to Einstein's theory of general relativity, gravity is not a force, but a curvature in spacetime. Imagine a bowling ball placed on a trampoline. It creates a dip, a curvature in the fabric of the trampoline. Now imagine spacetime as the trampoline and massive objects like stars and planets as the bowling balls. These massive objects warp and curve spacetime around them. This curvature of spacetime is what we experience as gravity. Neutron stars, they're like the Hulk of the cosmos. Incredibly dense, incredibly powerful, and they pack a mean punch. Imagine a star more massive than the sun squeezed into a ball the size of a city. These stellar remnants are born from the explosive deaths of massive stars in supernova explosions. And when I say dense, I mean really dense. Imagine taking a teaspoon of neutron star material. That tiny spoonful would weigh about 6 billion tons. That's like trying to fit all the elephants on Earth onto a teaspoon. Neutron stars are also incredibly hot, with surface temperatures reaching millions of degrees Celsius. They spin rapidly, some making hundreds of revolutions per second, like cosmic lighthouses beaming out radiation. So, the next time you see a tiny object, remember, it might just be a neutron star in disguise, a tiny but mighty force to be reckoned with. Ever wonder if there's another you out there living a different life in a parallel universe? Well, the multiverse theory suggests that our universe might not be the only one, but just one of an infinite number of universes. It's like a cosmic bubble bath, with each bubble representing a different universe, with its own set of laws of physics, its own history, and maybe even its own version of you. Imagine a universe where dinosaurs never went extinct, or a universe where you're a famous astronaut, or even a universe where gravity works in reverse. The possibilities are endless. Now I know what you're thinking, this sounds like something out of science fiction. And you're right, the multiverse is still a theoretical concept, but it's a concept that has captivated physicists and philosophers for decades. So the next time you're feeling adventurous, just remember, there might be an infinite number of you out there, exploring the vast and mysterious multiverse. Alright cat lovers, get ready for a thought experiment that'll leave you scratching your head. It's time to meet Schrödinger's cat, the most famous feline in the quantum world. Imagine a cat sealed inside a box with a device that has a 50% chance of killing the cat within an hour. Now here's the catch, according to quantum mechanics, until we open the box and observe the cat, it's both alive and dead at the same time. I know it sounds crazy, right? But in the quantum world, particles exist in a superposition of states, meaning they can be in multiple states at once until they're observed. Schrödinger's cat is a thought experiment designed to illustrate the bizarre nature of quantum superposition and how our observation can influence the state of a system. So, the next time you see your cat napping, just remember, it might be both asleep and awake at the same time, at least until you check on it. Thanks for watching. If you enjoyed these mind-bending physics facts, don't forget to like, subscribe, and hit that bell icon for more awesome content. We've journeyed through the vastness of space, from the speed of light to the mysteries of the quantum world. We've explored the weird, the wonderful, and the downright unbelievable, and we've only just scratched the surface of what there is to discover. So stay curious, folks. Keep asking questions, keep exploring, and never stop being amazed by the wonders of the universe.